In this lesson, we will examine how to identify that we have a limiting reactant problem when we are studying stoichiometry, and how to solve two different types of limiting reactant problems. One where we determine the amount of product that we would be able to produce from this kind of reaction, and the second type of problem is how to determine how much excess reactant is left over. Before we begin, we need to understand what the difference between the limiting reactant and the excess reactant are. A limiting reactant is the reactant in a chemical reaction that limits the amount of product that can be formed. It limits the amount of product that can be formed by being consumed first. It is the one that gets used up first in the chemical reaction and therefore stops the reaction from proceeding any further. So once it's been used, all of the possible products that can be formed will have been formed. The excess reactant, which can be more than one, the same as the limiting reactant, which can be more than one, is any reactant in a chemical reaction that remains when the reaction stops. So once the limiting reactant has been consumed and no more product is being formed, if there is leftover of one particular type of reactant, then it is referred to as an excess reactant. And we can determine how much of it is left over. First, we need to be able to recognize how to know that we're dealing with this type of a limiting reactant problem. In the previous problems that we've done, the basic mass-to-mass stoichiometry problems, we have been given information about one particular reactant in the balanced chemical equation. And so we've known that that is what we need to use in order to determine information about any other reactants or products. In limiting reactant problems, what you'll see is that you're going to be given information about more than one reactant. And when you're given information about more than one, you're not going to know which one the reaction is based on. So you need to identify first, before you proceed, the limiting reactant. We'll start with an analogy before we move into an example involving a chemical reaction. Let's look at the scenario where we are building cars. We have as our materials available 8 car bodies and 48 tires. And what we want to do is figure out how many complete cars we can make from these materials. In order to study limiting reactant problems, I find it useful to set up a chart to help me organize the data in the question. So what we're going to do is use this particular analogy to help us learn how to set up and use a chart, which we will apply in our chemistry examples. The headings of the chart are reactant, amount of product, and status. So in this case, our reactants are the car bodies and the tires. In the second column, we want to identify how much of the particular reactant we have. So for the bodies example, we have 8, and for the tires, we have 48 available. Now, this is the important column because we don't look at the amount of reactant that we have and decide that which one is the limiting reactant. By definition, the limiting reactant is the one that is not in the smallest quantity, but it is the one that makes the smallest amount of product. So we need to take it one step further and figure out how much product we can make based on the reactant that we have. So essentially what we need to do is look at these row by row. So we need to think about the scenario. If all I was given that I had 8 car bodies, how many cars could I make? The ratio here is 1 to 1. For every body that I have, I can make 1 car. So in this case, I could make 8 cars. For the tires, I have 48 tires available to me. So I need to think about without considering the car bodies, just how many cars could I make if I use up all of these tires? And I need 4 tires per car, so what that means is that if I use all of these tires, I would be able to make 12 cars. It is at this point that I can decide which one is the limiting reactant, because, as the definition states, the limiting reactant is the reactant that makes the smallest amount of product. The smallest amount of product is 8, so what that means is that the bodies are the limiting reactant. Anything that doesn't have the same amount, so in this case we could make more than that, this is going to be in excess. So that's basically type 1 of the problems, deciding how much product we can actually make. Type 2 of the problems is to figure out how much of the excess reactant, in this case the tires, is left over after the reaction. What we need to do in this case is look at, first of all, how much have we used. We made 8 cars. To make 8 cars, we're going to need a total of 32 tires, because we need 4 tires per car that we make. So we have used 32 tires in the process. So what is left over? The excess is 48 minus 32. So therefore, we have 16 tires left over. Let's look at an example using a chemical reaction. Type 1 is to find the mass of the product. We have the following scenario. A 2-gram sample of ammonia is mixed with 4 grams of oxygen. What is the limiting reactant, and what mass of NO will be produced? So first, we need our balanced chemical equation, which is given here. And what we have here is a scenario where we are given that we have 2 grams of ammonia and 4 grams of oxygen. Now, as I said previously, how we know that we have a limiting reactant problem is by the fact that we are given information about 2 of our reactants. So I'm not sure whether I need to base the amount of product that I produce on the NH3 that I have or the O2 that I have. So I need to identify first which one of these is limiting the amount of product that I have, or which one is the limiting reactant. Now I can't just look at this and say, oh, I've got less grams of NH3, that's going to be my limiting reactant, because as you know, that's not how we define limiting reactant. We need to figure out which one of these is going to make the smaller amount of product. Now in our little car analogy, we didn't really have units that we needed to work with because we were working with the quantities physically and we knew how much we needed for producing a car. When we're dealing with a chemical reaction and an example involving chemicals, we need to use moles in order to compare the amounts of substances that we have. So our headings here in our table, which we're going to use, are going to be the moles of reactant that we have and the moles of the product that we have. So I have 2 grams of ammonia. So in order to find the moles of ammonia, I need to divide by its molar mass. So I'm dividing by 17.04. For the oxygen, the O2, I'm dividing by 32, and I find that I have 0.125 moles of oxygen. Now, again, it's not at this point it appears from this example that the NH3 is limiting if you look at the amount of reactant, but that's not what we do. We need to know how much product. Now the first part of the question here is, what is the limiting reactant? So when we look at this, we might say, okay, well, which one do I base this example on? Am I going to look at how much NO is produced or how much H2O? And the bottom line is, you could determine this using either product. The product that I analyze could be either one, and I'm going to come up with the same result of which one's the limiting reactant. If it limits the amount of NO that's produced, it's also going to limit the amount of H2O that's produced. In these problems, if they're presented to you in a two-part format, it's a good idea to look ahead to the next part of the problem to figure out which one would be easiest to base the problem on. In this case, we're being asked to find the amount of NO, so it's easier to actually look at the amount of NO that's being produced based on the ammonia and the oxygen. So in this step, I want to use the NH3 to figure out how much NO would be produced. And really what I'm doing here is applying step 2 of my mass-to-mass stoichiometry problem. I have the moles of one substance, and I want to find the moles of another substance in the balanced chemical equation. So what I need to do is use the ratio. So for the case of ammonia compared to the NO, the ratio is 1 to 1. The 4 to 4 ratio is a 1 to 1 ratio. So the moles of NO in this case is going to be 0.11737. So if I use up all the ammonia, this is the amount of NO that I would be able to produce. In this row, I need to apply the oxygen. If I use up all of this oxygen, how much NO could be produced? The ratio between oxygen and nitrogen monoxide in the balanced chemical equation is 5 to 4. So for this one, I need to set up a proportion. So for every 5 moles of ammonia, I produce 5 moles of oxygen, I produce 4 moles of nitrogen monoxide. Therefore, if I have 0.125 moles of oxygen, I'm going to produce X moles of nitrogen monoxide. And when I cross multiply here and then solve for X, I find that I get 0.1 moles. So it's at this stage that I decide which one is the limiting reactant, which one is limiting the amount of product that I can produce, and that is going to be the oxygen. When I use up all the oxygen, I can produce 0.1 moles of NO. When I use up all the ammonia, I can produce 0.11737, which is a larger quantity. So this one is in excess. And this example was very purposeful in that even though the ammonia was in a smaller mass and a smaller moles, it ended up being the substance that was in excess. Okay? It's to emphasize the point that it's not about the amount of reactant that you have, because the individual substances will be reacting in different ratios to the products that we're studying. And that's what has a big influence and needs to be taken into account. So we haven't quite answered the question at this stage. We've identified the limiting reactant, and we've figured out how many moles of product can be produced, but the question is asking us for the mass of NO that can be produced. And so the mass of NO is equal to the moles of NO times the molar mass of NO. So we've got the moles of NO, and I tend to circle it once I've determined the limiting reactant, just so that I have it standing out in front of me. And I'm going to multiply by the molar mass of NO, which is found by taking the molar mass of nitrogen of 14.01 and adding the molar mass of oxygen Okay? And so what we find is that we can produce 3.00 grams to the correct number of significant digits. Okay? So that's how we solve type 1 problems where we're being asked to determine the mass of product that can be produced. Type 2 problem is to determine the mass of the excess reactant left over. And these ones tend to be more challenging because we've already got a lot of information in front of us, and sometimes people find it tricky to determine which information is important, which one's relevant, what do we need to use, what am I trying to find. So it's really important to take a step back from the problem and really think about what you have and think about what you are trying to find. So what we are trying to determine here is how much of the excess reactant, which in this case is our NH3, is left over. So we started with 2 grams of it, but we want to figure out how much of it is left over. So our first job is to figure out how much of it we used. And I find it easiest to rewrite the balanced equation and extract the information from the chart that's going to be helpful to me. And I like to base it on the product because that's the last piece of information that I found, and it's easiest to use because it's right in front of me. So I know that in this reaction, when I combined the ammonia and the oxygen, I was able to produce 0.1 moles of NO. And I need to figure out how much NH3 was actually used in that process. So I need to use the ratio. The ratio here is 4 to 4, which is 1 to 1. So the moles of NH3 that are used is equal to 0.1 moles. So the mass of NH3 that I've used is found by multiplying the moles that I used by the molar mass, which is 17.04, so I have used 1.70 grams. Once I've got this value, if I think back to what I have, it's not too difficult to figure out the mass that's left over. The mass left over is going to be what I had minus what I used. So I started with 2 grams and I used 1.7 grams. So therefore, I have 0.3 grams left over. So what you can do now is try one problem, and you'll just try type 1 for now. We'll have lots of opportunity to practice the other types. So you're going to, based on this problem, starting with 1.21 grams of zinc and 2.65 grams of hydrochloric acid, you want to figure out which one is the limiting reactant and determine the amount of zinc chloride that is produced in this reaction. The answer is 2.52 grams. Okay, so take a few minutes and try that problem.